Okay, we're going to go over some of the EDAX functions now. So first of all, we're starting out on simple mode. I'm going to capture just a simple analyzer of the entire field of view on here. We need to enter whether the sample is coded. In my case, it is. Go into the microscope setup. I'm setting it for a process time of 4, which I've worked out in advance, works for this sample. And I'm going to go into Acquire Spectra and grab a new spectrum here. There's a bit of a delay while that starts up. And there you can see it functioning. Right-clicking on here, we can add a scale bar. We can make that logarithmic if we like. You can drag it up and down. And you can also set the process region on there. So I'm going to stop that now that you've seen that functioning, and we're going to switch to point and ID. In point and ID mode, we go into our site of interest. We have the SEM already set up. This will be on a large aperture with a fairly large probe current, so you're not going to get high resolution and high magnification when you work in this mode. However, it should give you a decent image. So here we're going to grab a new site of interest here and click go. And you should see the lines sort of sketching out on the SEM screen itself and coming up here instead. Next, we go to Acquire Spectra. There's a variety of different tools. We have a point tool, we have a square we can draw, we have a magic wand tool that could recognize a full region. Try that out and give you a quick demo of that. So that one's getting the spectra from that whole area. Again, there will be a little bit of a delay while this starts up. And there you go, getting the spectrum from that particular spot. Right-clicking on here also allows you to go into changing the peaks on or the types of labels that you have. You can go into an editor where you can remove certain spectra out of there if you like, if you want to, or you can confirm various elements. So that's that functioning. I'm going to stop that again prematurely. And we're going to switch into mapping mode. So mapping mode, we need to set up our smart map. Sometimes you'll have to do a lot of adjusting in terms of what settings you're going to use for this, but we'll go into smart map. I think we've got this established already. I'm going to press go again. A little bit of a pause. And there we are starting to gather our elements for the smart map. I'm going to let that run for a few minutes. May take a little bit of time. So I'll just pause that while it's running, and then I'll show you the mapping functions when it's done. So just a little bit about this. You can right-click at any time to export your images as TIFFs or JPEGs from within the spectra. You can also go into the data tree and export your spectra from here. In addition, we can go into the reporting section. We can report our settings. We can report our image, our preview image. We can report the smart maps or any of the above. There's quite a few different settings, and those reports will go out as HTML files. Okay, so that's done here. Let's go into our element maps. Looks like I didn't get very stunning results there, so I'm going to try another one. Pausing for a moment. Okay, I've run another spectra in a different region here. I'm just going to give this a go. Go into the element mapping. As you can see there, I've got a little bit stronger peaks than I did the last time. I'm looking for silica in this sample. I'm also looking for carbon. I'm going to activate those by holding down the Shift key, click Mix, and it will generate me a map there in the top left corner. And this can be exported from here or either in the reporting section. Just to show you one that I did earlier today with a different area on the sample. this one was a little more robust, so I can show you exporting that as a JPEG. Desktop. And I'll just quickly show you that. So that one gave me a much more robust image earlier today when I was demoing it, and the recording didn't work at that point. So there you go. It does work quite well as long as you've got the right sample and the right settings. Okay, so that's enough for the EDAX. You can see it's working quite efficiently, and we're going to step out of there, and I'm going to go and show you some backscatter detection. Okay, here you can see we're in standard SEM mode on the system. We're going to put this in slow so that you can see it a little better. Got a little bit of charging artifact in there, so I'm going to just move around a little bit and find a better spot. Okay. So here's some different elements as seen in the regular SE mode. Switching over, you can go to the condition tab if you like, and switch to variable pressure mode once you've got your beam set up. This would allow you to look at uncoated samples or also slightly damp samples without the charging artifact. It is a little bit difficult to set up because it only works in backscatter mode, so I recommend you set up the beam in SE mode and then switch over to that if you're going to use it. If you were to turn this on while the beam was running, it would turn the beam off until it reached the proper vacuum status. So I'm going to just go to the image tab here and switch immediately to BSE without going in the low vacuum mode. I'll just take a second. We put it in detail here. Now, when you work in this mode, you probably want to put it onto, if you're going to adjust focus, I recommend you use the slow scan or the slow one mode rather than the fast scan mode in order to move around your focus. So there it is working in one of the 3D modes. I'll put it in slow here just so you can see that a little better. Working in the other 3D mode, takes a minute to adjust. I have this auto brightness linked, set to auto brightness link in the software so that you can automatically switch over. And I'm going to show you that all the detectors in the backscatter work. So there's the 3D with all detectors on. We've got topography from one direction and another. Let's put this on a little faster scan. I'm just going to put it on fast too. It'll be a little noisier. I'll show you that it's not the problem with the detectors. I'm just going to show you the different topographies. One, topography two. You can see the different detectors shutting on and off, and you'll see the shadows appearing in different corners of the dimples that are on the sample. Topography three, topography four. I'll switch that to slow mode so you can see that there's not a problem with the actual scanner. It's working fine. Back to fast mode there. And then our compositional modes, one. Shows you atomic weight differences by showing them as contrast in the image. And reverse composition mode should show you the dark spots as white and white spots as dark. So there you go. You can see that all the detectors in the backscatter are working. And I will close out of there and switch back to regular SE mode. So the only thing else I really need to show you are the stage functions. The stage can be controlled through the software. You can set it to move. Right now it's set for 1 millimeter of movement, so I can travel 1 millimeter in that direction. Fast. Travel 1 millimeter back in the direction I came from, and I'm right where I left off. So it's quite accurate. You can double click on the stage to move around on the visualization of the stage there to move you around. You can link when you want to use tilt mechanism. I'd have to drop it a little bit from here. So let's put this back out to like 20. And I will just briefly pause while okay, tilt mode can be set to either direction. In the right-hand direction, it will move up to 90 degrees if the stage is sufficiently far away from the backscatter detector. In the opposite direction, it's limited to a 20-degree range, so you need to pay attention when you load your samples, but nevertheless, I have a choice between focus linked and eccentric tilt. So focus linked will more or less keep me in focus as I tilt, so let's show that. I'll just tilt a little bit, let go. It is going to move across the sample as you see, but maintain focus. So there it is, just a minor bit of tweaking on the focus and you're right in there. Now that lost my point of view, so if I wanted to go back to 0 here, my other option is to click eccentric tilt. Eccentric will try to keep the same region in the middle of the field of view, but may lose focus. So a little bit of focusing. Let's get something we can recognize on there, this pattern of bubbles. A little bit lower in magnification there, and I'm going to put it on eccentric. And again, I will tilt it just 20 degrees or so. Click go. And it should sort itself out and bring itself back to the location that it, no, apologies, I didn't unclick this. Let's try that again. Keep it on eccentric, put it back to 0, click go. And there you are, you have yourself back where you started from. Okay, I think that's all the functions. There's a stage navigation history in here. There's a stage memory where you can program positions into there. And I think there's also the option to turn on and off these different modes on the mouse. So at the moment, if I click in each of the quadrants, I can control the brightness and contrast, I can control the focus, and I can control the stagnation. Using the mouse wheel within there, you can also turn that off if you prefer. We've got, or my preference personally is that we have a control panel here that allows us to do all of this by dialing in. So it's going to allow me to shift where I am located. Here's my magnification control, control over the stagnation. These are also the buttons you use when you're in alignment mode and need to align the beam, course, and find focus. And we've got our brightness and contrast settings. There's our trackball, keyboard. There is a high mouse function in here that can allow it to switch from operating the EDEX and operating the SEM using the same mouse. I tend to keep them separate on here, but that can also be set up. So I think I've covered just about everything about the functions of the machine, and I'm going to sign off now. It's been a pleasure.